Good day everyone. Welcome back to the Azure Databricks series, and today we are diving into something super important for anyone working with large scale data architectures, the hub and spoke model in the context of Azure Databricks. We will discuss what this architecture is, why it's useful, and how it can help improve data security and scalability. Plus, we will look at some real world examples to see how this model can be applied in enterprise environments. Stick around till the end, where we will also touch on the advantages and possible disadvantages of using this architecture. Let's start with the basics. The hub and spoke model is an architecture pattern commonly used in networking, but it has become highly relevant in cloud data platforms like Azure Databricks. Here is how it works. At the center, you have the hub, a central virtual network that acts as a control point for the traffic and security. Surrounding it are multiple spokes, individual, isolated virtual networks where different resources or workloads are placed. In the context of Azure Databricks, your hub could contain shared services like logging, monitoring, and security rules, while the spokes are individual workloads or data processing environments, each isolated to ensure better security and governance. The idea behind this model is to centralize common services and allow spokes to operate independently while still being connected through the hub for essential services. The hub typically contains shared resources such as your Azure Firewall, Azure Private DNS, and Express Route Gateway to connect to on-premise environments or the internet securely. Each spoke contains resources like Azure Databricks Workspace, Azure Storage Accounts, and other application services needed for specific workloads. The spokes are isolated from each other. So if you see here, we have spoke 1, spoke 2, spoke 3, and we have many other spokes. All these things are completely isolated to one another. So they basically have to go to the hub, get the things. So hub is the only way that connects each and every spoke. This ensures that even if one spoke is compromised or experiences issues, it doesn't affect the others. But they are still connected to the hub, which means they can share common services such as logging, monitoring, and security policies. As you can see, the hub acts as the nerve center of this entire architecture, while the spokes are individual workspaces or environments like dev, test, and prod, each using its own Databricks cluster. For example, in a real-world scenario, a large enterprise can have multiple teams working on different data projects, isolated in spokes, but centrally managed through a single hub. Now let's talk about why this model is so widely adopted, especially in large-scale environments like Azure Databricks. The single most important reason is the improved security. The hub centralizes the security features such as firewalls, network security groups, and policy enforcements. This ensures all traffic coming in and out is controlled and secure. It is highly cost efficient. By centralizing shared resources in the hub, you reduce the need for duplicating infrastructure like VPNs, firewalls, or DNS across multiple environments. It is highly scalable. As your organization grows, you can add new spokes without needing to redesign the entire architecture. This means you can quickly spin up new Databricks workspaces or environments for different projects. Governance, centralizing security, logging, and auditing in the hub ensures that your organization maintains strict governance policies across all environments. They are highly isolated. Each spoke is isolated from others, ensuring that workloads in different spokes do not interfere with one another. As with any infrastructure, there are some potential downsides to consider as well as the hub and spoke model as well. The first and most important disadvantage is the complexity that is involved. Managing and maintaining the hub can really become very, very complex, especially as the number of spokes gradually increases. You need to ensure that routing, security rules, and governance are consistently applied across. There can be latency issues. In some cases, the additional network hops between the hub and spokes can introduce latency, which may impact performance, particularly for data-intensive workloads in Databricks. Cost management is both an advantage and disadvantage here. Now, if we talk about the disadvantage, while you save costs by centralizing services in the hub, there can be added costs for network bandwidth, especially if data traffic between the hub and spokes is significant. One of the main reasons to use the hub and spoke model is to enhance security. Let's take a real world example of how this model secures your data in an Azure Databricks environment. First, traffic between the spokes and the hub is typically secured using private endpoints and express route for private connectivity. By utilizing Azure Firewall or network security groups in the hub, you can enforce strict rules, ensuring only authorized traffic flows between the different spokes or to the outside world. Yeah. You can also integrate Azure Active Directory for central identity management, ensuring consistent user access across spokes. Moreover, logging and monitoring services in the hub also allow you to track and audit any security breaches or unusual activities across all spokes. Imagine you have a Databricks workspace in one spoke handling sensitive financial data. You can use the hub to set up a private link to your on-premise SQL server for secure data retrieval. At the same time, another spoke might handle less sensitive marketing data, but still use the same centralized security protocols, ensuring data isn't exposed to the public internet. So there you have it, a comprehensive look at the hub and spoke model in Azure Databricks. We discussed the architecture, its benefits, potential downsides, and most importantly, how it can secure your data in real-world applications. If you're building out large-scale, multi-team data environments, this model is incredibly powerful, providing a good balance between isolation, scalability, and security. I hope you found this video helpful. If you did, please give it a thumbs up and consider subscribing for more deep dives into Azure Databricks and other cloud services. That's it for this video. Thanks for watching. Have a great day. Jai Hind.